Okay, let's go over 2.x features, and I'll try to extend the performance enhancement aspects that go beyond what Roshan has mentioned already, and we have talked to. Uh, some of the I'm going to give quick summary of what 2.x includes: performance improvements, scalability enhancements, and uh, certain scheduling improvements that will take us to the next level in terms of performance. We'll talk about generic resource aware scheduling and how network is becoming a more concern going forward with all the improvements that we're going to make with the CPU and memory. Certain security aspects that we have covered: backward compatibility, metrics 2 API, newer 2.x API, SQL streaming as a beta version, streaming APIs, ease of use, NUMA awareness, container support, and future work. I'm going to exclude what is covered by Roshan here, which is 2 back pressure, but for sake of completion of this topic, I've just mentioned it here. Just to give you a quick update from the Apache 2.x, like really we have 119 new features, 293 improvements. So a lot of changes and a lot of bug fixes that have gone in as part of 2.x release. A lot of dependency upgrades. Okay, speaking of performance enhancements, this is a standard benchmark we run for Storm in a single workers versus 2 workers. And what you can notice is comparison over 2.x. What you notice is for the same amount of the latency really kind of is improved, and as throughput kind of keeps going up on a single worker, you see that like there's a 50 to 80% improvement, and there's a consistent gradual degradation versus exponential degradation here. It's a degradation is really linear. 2 workers, what you really notice is the cost of serialization and deserialization between workers is really still adding constant overhead in terms of latency and not exponential again. If you have any questions, please stop and start talking. I'm not seeing anything on the screen apart from what I'm presenting, so don't hesitate to speak up if you have any questions. Another aspect, which is what is the resource utilization and CPU. This is taking to the next level where basically it's linear, but it's still much lower. What you also notice is in the early portions of the topology at the launch time, at the submission time, what you notice is there is a typical smoothing of this line has happened, and it's not. And I'll talk more about why that aspect is important and how that has come into picture. Again, throughput, we are really able to see that we have gone way beyond 60,000 sentences per second, and which is, I think, which was like for the same amount of CPU and memory, it's kind of tremendous achievement. Coming to a bunch of improvements have happened. One of the things as a Apache Storm community, we switched to pure Java implementation and removed Clojure to bring community closer together. And there used to be something called JStorm that is merged in. With 2.x, we've finished that migration for Clojure, and now lazy initialization is reduced, and hence you see that the curve at the beginning of the launch of topology is kind of smoothened out. And the GC overhead is also kind of lowered now because of number of queues that have gone down, and hops that happen, and number of objects that get created and destroyed throughout. Messaging subsystem to back pressure are obviously the 2 major contributors to the performance. Scheduling changes have happened a lot more in terms of so going beyond 1 worker. Cost of serialization, deserialization really starts to go up as the number of workers and the size of the topology goes up. So there are certain improvements in the scheduling logic that I'll talk about in the later slides, but really helping us lower the penalties of serialization. Load aware and locality aware shuffle grouping and additional grouping Grouping has also helped us lower the hops that a particular event will take across workers or across the racks. Uh, Optimize GC, there are certain aspects to the optimization that are standardized now that help us get closer to improving performance. Other scheduling changes and GRAS giving you visibility into network and GPU. We'll talk about that as well. Again, this is something he has covered already. Scalability and so less reliance on Zookeeper. Zookeeper has always been throughout the lifetime of Storm's existence has been major blocker. And previously we in 1.x we had introduced Pacemaker. With 2.x there are certain changes where uh, Nimbus and supervisor communication is we dropped Zookeeper from that communication and assignments, and cluster state is communicated directly by Nimbus to supervisor. That short circuiting has helped us speed up things in terms of responses to the changes in scheduling state, as well as stats that get reported now via supervisor heartbeat, and that uh, workers report to supervisor and supervisor reports them back to the Nimbus. So there's a pacemaker as well can be dropped at this point. High availability was another feature. We try to introduce that with 1.2, but with 2.x there were certain bugs fixes with the high availability, and that's much more stable at this point. Okay. Scheduling improvements, I think blacklisting is one aspect where a node can go bad for whatever reasons, and there can be more than one reason, but there is blacklisting logic that kind of keeps the bad nodes or recently added nodes for a certain time period into the blacklisted blacklist and brings that back into the role. And it's there are two aspects. One at the topology level blacklisting, and overall for all topologies or anything that is running in a multi-tenant environment. Locality awareness, obviously the shuffle grouping has locality awareness, so if tuple doesn't need to bounce across, and it uses load awareness as well as part of this. So locality and load awareness, so if which reduces like possibility of serialization, deserialization, or network hop. So most probably it will be a loop back into the same machine, or try to avoid the rack switch. Uh, Grouping for network, this is something that uh, we really needed to understand. Like this is right now experimental feature. I'll go prime in 2.2, but it's really, this is at the scheduling level where we decide how the scheduling needs to happen, and it's a continuous scheduling, so it takes into account the fragmentation that might have happened in the cluster already, and tries to lower the hops as well as lowers the as part of the scheduling itself and not while it's running. Uh, Again, we talked about GRAS before and after. Obviously, the before we only considered CPU and memory as resources. Now we are able to consider network as a resource, because with CPU and higher CPU and memory boxes that are coming out of the into the works, the processing power is really high, and network starts to become bottleneck. And now ability to understand how much is the network as a resource available, what is the congestion, that's really a concern at this point. So we are able to use that, and we can use GRAS now to determine how much network is needed for a specific component, a spout or a bolt, and based on that the scheduling will adjust to it, giving a better performance and stability for the lifetime of the topology. Uh, Again, jumping to security, there are a bunch of them, and these are some of the issues that we had noticed, and we took sufficient time to fix them. And there are many more dependencies that were part of the dependencies that we borrowed and extended, which needed to be removed as well. So security-wise, it's better option right now than what 1.2 was. Backward compatibility, this is an important feature both for our people who are already running this and who needed to migrate to 2.x and use all these newer features. It works, and in multi-tenant clusters especially, it's important to allow users to migrate to 2.x at their own pace. So backward compatibility worked as an excellent feature, especially for within Verizon Media and outside. Okay, so again, this small things on the UI which really tell you topology version, cluster version, and the dependent storm backward, whatever the version of the storm the topology is compiled against, become useful in tracking changes that are happening on the cluster. So this ease of use and ease of really upgrading the topology. There is APIs are compatible. It's just the package change, and most of the dependencies are shaded. So that's kind of faster for users in terms of switching existing topologies. Metrics API, since written for the first time, which was metrics like was written 2013, there were really much more improvements needed because everything was turned into an object and you would lose the data types and everything becomes a number essentially when it goes into the metrics reporting system. It used to travel via as system tuples that go from every component, every worker onto the consumers for the metrics consumers, and then get propagated and published to the metric store. This was not effective, as well as it was kind of slow. It could slow down the performance, but the fact that metrics, if the system is overloaded, the metrics itself will become unavailable at many times. So now 2.x API really, it relies on drop wizard. All the metrics types are really primary members, so people can define their topology, these metrics at their topology level, and they are being the primary members of the system. They will get reported as histogram or as timer with min, max, and average counters. Also, we added different. So these new API is available, so you can use that, or you can come up with your own custom metrics. But essentially, what it becomes is different reporters are available, and these reporters really have ability to publish as a to local node or to a metric store, and it does not rely. Metrics don't need to hop over to different network components or to different components across topology. You can directly route them into your RocksDB or time series database. This is effective. Also, Nimbus is able to store these metrics into the metric store and retrieve them if you need to look at the historical data for a particular topology. Stream API with JDK 8, we really need people like to use stream, turn every stream into a literally stream kind of API and start using a shorthand while writing a simpler pipelines, and this is what a typical pipeline looks. It's one of the use cases for this is people who are really used to writing using Stream API and they prefer to write it that way. It just becomes a useful feature for the users instead of trying to use inconvenient API that is older API. Streaming SQL. We added streaming SQL in a beta version. It uses Scalside for parsing SQL, really closer to the Hive data definition language. Implementation is not native to Storm, so some of the things, the aggregation and joins are not supported at this time. Eventually, it will become native, and we will be supporting these functionality as well. So streaming from external sources is possible. Filtering tuples in an existing stream, providing projections, or using user-defined functions which are really scalar are supported at this time with 2.x. We're still reporting this as experimental and beta version because obviously we don't have a aggregation and join kind of support for this. Some of ease of use, moved away from Clojure. So communities Clojure, you can read the code easily. People who don't like Clojure can straight jump into the Java code, write their topologies as well as contribute to the Storm. Split class path, again, this is separating the daemon class paths from the user class paths. So topologies have smaller size as well as shading kind of helps have Storm client have smaller footprint on the machine as well. Okay, move to Java 8. Yeah, it took us some time to get there. And SQL again is part of the introduction, just still at the beta version. Some of the other performance and NUMA Awareness has come, but it's going to be primary feature in 2.2. Right now it's in the people are reviewing it kind of stage. So with the nodes becoming bigger and bigger, we do have need understanding for the NUMA architecture, and it does affect GC performance if system is not NUMA aware. So now the schedulers are NUMA aware, and they kind of make sure that the scheduling happens looking at the NUMAs and hardware. So this gives a very consistent performance and better performance for larger memory using topologies. Container support, that's again in the works. 2.2 will have this. All the benefits of running as a Docker container or runC containers like Hadoop does. Separating namespace and some security aspects involve benefits of any Docker containerized solution are coming there. It also integrates with NUMA Awareness, so further consistency in terms of performance. And users can customize their images, so dependence on native libraries and deployments is avoided. Future work, elasticity, shrinking and growing topologies dynamically. That's the work that we're trying to get it, but it's slightly more challenging than Hadoop overcommit kind of methodology of trying to get to elasticity. There is a potential for doubling capacity, and how do we accomplish that is the question. We're working on that. Kubernetes integration for elasticity. Right now, we do have Kubernetes support, but that's really a very basic, which brings up a standard standalone Storm cluster of a fixed size and does it. What we want to use this Kubernetes is for providing further elasticity into a given topology and be able to add and relinquish resources based on the needs. Again, network congestion. Right now, there is no visibility with 2.x. In future, we plan to bring in the visibility into the network congestion and making scheduling aware of existing congestion and work around with it. So that's it, guys.
Well, Kishore, thank you so much. We're going to clap for you, and I hope you can hear it on this microphone.
Thank you, guys.
Thank you so much.